So today we're going to be doing 268 missing number, and it says given an array nums containing n distinct numbers in the range of 0 to n, return the only numbers in the range that is missing from the array. And in example 1, you see nums, the nums list, it has 301, right? It obviously wants you to return 2 because 301, if you just count it up in your head, you can see that 2 is missing. And example 2, 0, 1, there's no missing number, right? But all you have to do is just return 2, which is the next number. In example 3, I'm not going to count all this up, but basically the list is, it goes up to 9, right? But it's missing the value 8, so you just return it. There's a lot of ways to go with it, but I'm going to show you guys 2 ways I would attempt this problem. The first one, I'll show you the hashset way. If you guys know what a hashset is, good for you. But if you don't, you guys gotta watch a YouTube video on it. But basically, I'm gonna throw. Let's use example 1, right? It's 301. Let's just throw these in there. My bad. I'm using my mouse pad right now because I'm in my dorm, so I don't have access to a mouse. But yeah, this is the hash set. This is the hash set, right? Basically, we're gonna be looping through the whole thing. We're gonna be looping through the length. We're gonna use the range function and loop through the length of the list, which is called nums, right? I'll write it out right now. So for I in range of the length of nums, right? For I in range of the length of nums. So you know, there'll be another parentheses. So you know that it loops through the length. And basically what we're going to be doing is that we're going to reference the values that it loops through, I. If I not in hash set, all you have to do is just return I. Because it's gonna be looping through like one is inside there, right? Two is not inside there, so all you have to do is just return I. A better example is like maybe like 1, 2, 4, right? All it's gonna do is loop through the length again. It's gonna see 1 is in there. 2 is in there. Is that oh shoot, 3 is not in there. So I'm gonna return this value. But the thing is, it's not gonna work for every case, obviously. Because let's say we use this example down here, example 2, where nothing is missing, right? The if statement is only gonna work if it's not in the hash set, right? But let's see. Let's draw out the hash set. 0, 1, right? Yeah, this is only gonna work if it's not in the hash set. But there's no missing number, so all you have to do is actually just return the length of it. Because amazingly, return length of nums. Amazingly, it actually gets the next value, because like the length of nums, it starts at 1, right? So 1, 2, it knows that this whole thing is 2. So you just return that. Hopefully that makes sense for you guys. Yeah. Let's draw out the question. We're literally gonna write the solution right here. Okay. So we're gonna start with the hash set, right? We're gonna call it set of nums. Use the set function to make a set. All you have to do is use the function, the built-in function, Python function. If you're using another library, that's too bad. Yeah, you're gonna have to write it up yourself. But another language, you have to write it up yourself. But yeah, for I in range of length of nums, right? If I not in hash set, just return I. Here, let's run it down here. We're running it. You're gonna see we get like some type of error, right? Type error, none is not a valid value for the expected return type integer. because it has nothing to return in this example too, right? So you just want it to return the length of the nums, because it's 1, 2, and it gives you the output 2. And it'll work for that all times, right? You run it, and it'll say all 3 test cases passed. If you guys want to talk about time complexity, we can say the time complexity is O of n, because we're looping through the list, right? Only once. Space complexity is also O of n, because we're using a hashset, which requires some memory, and the hashset grows with the input itself, which is nums. So yeah, time complexity of O of n, space complexity of O of n, right? Okay, let's go on to the next solution. This is like my favorite solution, but it's not very intuitive. If you guys know this person called Carl Friedrich Gauss, he made a formula called n times n plus 1 divided by 2. It'll give you the expected sum, right? All you have to do is use this formula and take its value and subtract it from the actual sum of the list, and it'll amazingly give you the answer. And I'll show you how it works for you guys, because you guys might not be able to see it at first glance, but we know the formula is n times n plus 1 divided by 2, right? If you guys taken like this, if you guys are familiar with this formula, or like, it's kind of self-intuitive, but n is the length of the whole array, right? So n is the length. Right? So you can see the length is 1, 2, 3. So n is 3 times 3 plus 1, all divided by 2. If you guys are familiar with PIMDAS, you're going to want to focus on the parentheses first. So 3 plus 1 is 4. And then 4 times 3, right? 4 times 3 is 12. And then you do 12 divided by 2, which is 6. Right? That's the expected sum. This is the expected sum. This value is the expected sum. Now you want to actually sum up this whole thing. 3 plus 1 is 4, right? You're going to do 6 minus 4. And wow, it gives you 2. Amazingly, right? And you don't even have to do that edge case, like I said, if like all the missing numbers if there is no missing number. It actually still returns 2, amazingly. You know? So I'll show you guys how it does. So let's have 0, 1, right? There's no missing number. So let's get the sum of it first. So what's 0 plus 1? It's 1, right? So the sum is 1. Now we have to use Gaussian's formula for the expected sum. Expected. Sorry, I'm using a mouse pad, so it's kind of goofy. Expected, right? We're going to refer back to this formula up here, n times n plus 1 divided by 2. We know n is the length of the list, which is 2, and 2 plus 1 divided by 2. 2 plus 1 is 3, and then you multiply it to 2, that's 6. You would do 6 divided by 2. And if you guys are familiar with division, that's 3. 6 divided by 2 is 3. And then that's the expected, right? That's the expected. And then you want to subtract it by the actual sum, which is 0 plus 1. You get 3 minus 1 equals 2. And amazingly, it actually gives you this value right here. It's very great. So I'm going to show you guys how to implement it, right? Just keep it. I'll write out the formula right here. Divided by 2. I'll just floor division it. But let's make a variable called n to hold the length of nums. And now we can really just do expected equals n times times n plus 1. Oh, sorry. N plus 1 divided by 2. We're gonna use multiplication. You have to use multiplication symbol right here because like Python, it's not gonna realize that you're trying to multiply it if you're just doing like this, right? So you have to actually like specify it right here. You're gonna want the actual sum. So the actual sum is just the sum of numbers. And at the end, like I said, use return expected minus actual. We're gonna run it. I'm sorry you guys can't see the bottom of the screen where it shows like the run and submit button. It's my first time recording on this laptop and I was trying to crop it, but I guess next time I'll include it. But let's run it. Yeah, you can see that it works, right? Let's talk about the time complexity. Time complexity is O of n because you only go through the input once, right? And then the space complexity is O of 1. You don't need no extra memory for this. So yeah, that's why I like this solution more. It's not intuitive, but once you learn it, it's a lot better than the other solution in my opinion. It's more straightforward. This formula can be applied for like many other problems, so you should definitely like learn how to use it, this formula right here. It's pretty good. But yeah, let's submit. Here, I'm gonna write some comments out for you guys. Taking the length of nums and it will be n and it holds n. Right? Getting the expected sum using Gaussian formula and taking the actual sum of the list. We call it list because in Python you call arrays lists. Like, there's actually not a thing called an array in Python, if I'm not mistaken. But yeah, now we just return the expected minus actual. Because it will always get you the right value. Right? No, let's submit. Yep. Looks like it works. And thank you so much, guys. I'll catch you guys later.